Okay, so in this lesson, we're going to continue applying linear equations, this time to word problems. All right, so the best way to start, let's get into a problem. Two pools are being filled with water. So I'm going to make a little chart. First pool, second pool. Okay, to start, the first pool had 992 liters of water. And the second pool was empty, meaning it had 0 liters. Water is being added to the first pool at a rate of 16 liters per minute. So added 16 liters per minute. And then the second pool gets it added at 48 liters per minute. Okay, and let X be the number of minutes that water has been added. So part A, for each pool, write an expression for the amount of water in the pool after X minutes. So for the first pool, we start with 992 liters. So before they start filling it, there's 992 liters of water in the pool. And then 16 is added every minute. So it's 16 times the number of minutes, which is called X. Okay? So it's going to be 992 plus 16X. For the second pool, we start with 0 liters because it's empty, but we add the water a lot quicker. We add it at a rate of 48 liters per minute. So that would be 0 plus 48x. We can ignore that 0 and just write 48x. Okay, part B, write an equation to show when the two pools would have the same amount of water. That would mean first pool is equal to second pool. Okay, the amount of water in the first pool is equal to the amount of water in the second pool. But from part A, the amount of water in the first pool was called 992 plus 16x, and that would be equal to 48x. Okay, the problem doesn't require you to solve the equation, but if we wanted to know when the pools would have the same amount of water in there, we would solve for x, and then it would tell us, for example, that after 30 minutes or whatever it is, the pools would have the same amount of water inside of them, okay? So essentially they're like taking a hose and adding water to one pool, taking a different hose and adding water to the other pool, and we want to know after how many minutes would they have the same amount. Okay. So number 2, Carmen will choose between 2 restaurants to purchase pizza for her party. So I'm going to make a chart. First restaurant, second restaurant. First restaurant charges a delivery fee of $4 for the entire purchase and $11 per pizza. So delivery fee and then per pizza. So the delivery fee for the first restaurant is $4 and charges $11 per pizza. Second restaurant, no delivery fee, so delivery fee is 0 and charges $12 per pizza. Okay, just like number 1, write an expression for the total charge of purchasing X pizzas. So to purchase a pizza from the first restaurant, you got to pay the delivery fee and the price per pizza, and X stands for the number of pizzas. From the first restaurant, delivery fee is $4 plus $11 times the number of pizzas, or plus 11X. For the second restaurant, no delivery fee, so it'd be 0 plus 12 times the number of pizzas. So we can ignore that 0 and just write 12X. Write an equation for when the total charge with delivery would be the same at each restaurant. So first restaurant equal to second restaurant. So if we substitute what we got in the top, 4 plus 11x equals 12x. All right, number 3, now we're going to actually start solving the problems instead of just setting them up like we were doing in the beginning. Okay. So number 3, a total of 392 tickets were sold for the school play. They were either adult tickets or student tickets. So we two different type of tickets, adult and student. The number of student tickets sold was 3 times the number of adult tickets sold. How many adult tickets were sold? Okay, if we go back to the beginning, a total of 392 tickets sold were for the school play. That means the number of adult tickets sold, A, plus the number of student tickets, S, equals 392. Okay, that's what the first sentence translates to algebraically. Then if you go to the third sentence, the number of student tickets sold was, so S, the number of students sold, was 3 times the number of adult tickets sold. So that would be 3A. Okay, so we have 2 equations with 2 variables. We want to get this down to an equation with just 1 variable. So what we can do here, we know S is equal to 3A. So from the top equation, I can get rid of S, and we know S is equal to 3A. I can just put in 3A there. So that gives me A plus 3A equals 392. Combining like terms, 4A equals 392. And of course, we will divide each side by 4. So A is 98. Okay, which is what we were asked. So the adult tickets sold was 98. But if you were asked the student tickets, to get the number of student tickets, it's 3 times 98. Hey, what's up?
Just finished reading Melissa's email
Yep.
about that. So I'm anticipating we're going to just move that into Thursday, Friday.
Oh, I don't. So, yeah, I have everything in Classroom. Let me see. Oh man, I can't keep all this straight.
I probably should share one of my classroom or on my.
No, I do. I have one of yours. Yeah, no, I do. I'm just, balancing the 2 sides. Yeah,
Yeah, that's balancing is a good word for it.
yeah,
I'm kind of jumping on a ledge.
yeah. Okay, so we have what I put in. I put in geometry applications part 1, geometry applications part 2. I'm assuming both are going to be complete based on what Melissa wrote. Okay, so we've given 2 quizzes. They've taken 2 quizzes, so no, we don't. I mean, they come back on a Thursday, so we'll maybe a quiz the following week, but not that week that they come back. I mean, it seems pretty straightforward. Thursday's part 1 and Friday's part 2 of consecutive integers.
You want me to change the dates on those?
Please.
Okay.
And what was I gonna ask? I wanted. What was it that I was gonna ask you? I can't think of it.